Hello and welcome again to another past paper question which would be focusing on calculating the volumes of the gases. So here again I've put in the formula for references. Here's the past paper question. You can stop the video for a minute and read it. So over here, this is given to us 0.1 mole of hydrocarbon, which is combusted, and they are asking what volume of CO2 is produced when this amount of hydrocarbon is combusted, is burned down, measured at the volume is measured at RTP, which is for 1 mole, it's 24 dm cube at RTP. So moving on to the steps, step number one, write down the equation of the reaction, which is already given to us in the question. Step two is look for the known and unknown quantities in the question. So yeah, so what is known? We are known with 0.1 mole of the hydrocarbon C5H12, which is over here in the reactant. So this is the known thing. And what is unknown? Unknown, which we have to find out, is the volume of the carbon dioxide. And over here, it's one of the products. So this is the unknown, which we have to find out. So as in previous examples, we are standing over here. We need to calculate the moles. In this question, moles are already given, so we don't need to calculate them. By using the molar ratio, we will be moving over here and deducing the number of moles of CO2 which are produced, and then from the moles of CO2, by using a suitable formula, which in this case would be this one, mole equals to volume of gas over 24, and we will be able to find out the volume of CO2 as we will be deducing the moles of CO2 from here. So step number two is done. We have known, we looked at the quantities and marked them. Step three is calculate the moles from the given quantity of known substance. That is over here. This is the known substance. Calculate the moles. Moles are already given. The question is made easier for us. So it is already given in the question. 0.1 mole of C5H12 are used, is burned down in this equation. So step number four is that write the molar ratio between the known and unknown substance using equation of reaction. So we can see that behind the C5H12 there is number 1, and behind this CO2 there is 5 after the equation is balanced. So 1 mole of hydrocarbon is giving 5 moles of CO2. This is our molar ratio, and here I've written it in statement form. 1 mole of C5H12 is producing 5 moles of carbon dioxide. So next step, by using this molar ratio, we are going to deduce now that how many moles of CO2 are produced when this 1 mole is actually 0.1 moles of C5H12. So 1 mole produces 5 times CO2. So if we did this 0.1 as over here, so therefore 5 times of 1 is 5. So if we change this to 0.1, we will have to do 5 times to find the moles of CO2, as the ratio is 1 is to 5. So 0.1 mole of C5H12, we do 0.1 multiplied by 5, and that gives us 0.5 mole of CO2. So 0.1 mole of this is giving 0.5 mole of CO2. So now moving on to finding out the volume of this CO2 using this moles which we calculated, we will be using the formula moles equal volume of gas over 24. We are going to use this one. So step number 6, calculate the required quantity. Moles equals volume of the gas over 24. We are doing at RTP, so therefore this is 24. We have to find volume, move 24 to the other side. This is moles into 24, 0.5 we got from here into 24, and that gave us 12 dm cube. So our answer is 12, which over here is number D. So we will be marking this. Once again, this is an MCQ, so you don't need to do these detailed working. You can do them in rough as far as you can understand them and mark the correct answer. However, if this question appears in theory papers, so you need to do it neat and clean in order to gain good marks and maybe some bonus too. So that's it from here. Thank you.